A blast furnace performance hinge on a delicate balance between the two fundamental forces, the downward movement of the solid burden and the upward rush of the heat. Understanding this dance is the key to unlocking peak efficiency. So let's begin. Think of the furnace as being governed by two pillars. The first, stock movement, the steady, predictable descent of coke and iron ore, and second, the temperature profile, the heat map from the 200 degrees centigrade plus 2 years to the top gas. Now these two are very closely linked. Now smooth descent enables ideal heating and the right heat ensure smooth movement. Here is the ideal temperature gradient. At the top, the body is preheated as it descends into the cohesive zone. Temperatures between 800 to 1200 degrees centigrade allows for indirect reduction. Finally, in the combustion zone, temperature exceeds 2000 degrees centigrade, melting the iron and slag. This is smooth, predictable gradient is essential for the efficient gas use and reduction. But this profile depends entirely on the stock movement. Even descent forces gas through all body layer creating a stable profile. However, irregular movement often from excess fines cause channeling. The gas flows unevenly creating hot spot and leaving cold unreduced ore. These destroy our ideal profile and kills efficiency. This is where we can take control using blast moisture with a dry blast. The temperature rises steeply, but when we add moisture, a powerful reaction occurs in the tuer zone. The water vapor dissociates, absorbing massive energy and acting as a heat sink. This deliberately cools the lower furnace, shifting the entire temperature profile and giving us a critical lever for stability. So, why does this matter? Controlling the profile is a direct lever on your bottom line. It allows us to optimize the furnace's thermal state for our raw material, preventing refractory damage from the overheating. A stable profile means higher productivity, a lower coke rate, and a more predictable, profitable operation. This system is vulnerable considering poor coke quality. It creeps fines which disrupt stock movement. This leads to channeling and an unstable temperature profile. To compensate, operators must often increase coke rate, which can worsen the problem, creating a viscous cycle of rising cost and falling output. So let's recap the key message. One, stable stock movement is non-negotiable for an efficient temperature profile. Two, that profile is not static. We can actively shape it with tools like moisturizing the blast. And three, mastering the relationship is what separates a good furnace operation from a truly excellent one.